In today's lesson, we're going to learn about multiplying and dividing radical expressions. When we're multiplying and dividing radical expressions, we're simply dealing with expressions that have radicals in them. We have two rules. The first one is multiply like a regular polynomial. The second one is to simplify the radicals. We know how to do all of this. It's just a matter of now putting it together. This first example we're going to look at is the square root of 7 plus the square root of 2 times the square root of 3 minus 6. This is a basic polynomial. We're going to follow our FOIL process. So when we multiply our first, we have the square root of 7 times the square root of 3. That turns out to be the square root of 21. When we go outside, that's the square root of 7 times negative 6. So it's going to be minus 6 times the square root of 7. When we go inside, we have the square root of 2 times the square root of 3, which is the square root of 6. That's a positive 6. And when we go last, we have the square root of negative 6 times the square root of 2, or negative 6 times the square root of 2. And so this is our FOIL. And now we just need to look and see if there's anything that we can go ahead and simplify out of this. Let's look at our 21. It just has 7 and 3. 7 doesn't have anything that can come out of it. 6 is just 2 and 3. And 2 doesn't have anything that can come out of it. So this is as simplified as it can get. Let's go ahead and look at another one now. Let's look at the square root of 5 minus 7 times the square root of 5 plus 7. You might notice this is the product of conjugates. And if we think back, that means it's going to be the difference of squares. So we already know how to solve this without using the FOIL method. So when we think about this, we have, if it's the difference of squares, and we have the 5, so it's going to be the square root of 5 squared minus 7 squared is 49. And when we look at this, we have a square and a radical. Those cancel out. 5 minus 49 equals negative 44. Let's look at one more before we move on with some different types of examples. We have the square root of 3 minus the square root of 2 squared. Now if you remember, that means the same as the square root of 3 minus the square root of 2 times the square root of 3 minus the square root of 2. Again, we're going to use FOIL. First is 3 times 3, square root of 9. Outside is 3 times negative 2, square root of 6. Inside is negative 2 times 3, square root of 6. And last is negative 2 and negative 2, so that's going to be positive square root of 4. And we can simplify this sum. We can go ahead and do the square root of 9 is 3. We have basically a 1 here, so 1 minus 1 is minus 2 times the square root of 6. And then the square root of 4 is 2, and this is our final answer here. Here's an interesting example that comes in the form of a division problem. 4 plus the square root of 3 over 5 plus the square root of 3. We want to get rid of this radical in the denominator, right? So what we do when we have a radical that we want to get rid of, we multiply it by its conjugate. And whatever we do on bottom, we have to do on top. So let's look at the conjugate of 5 plus the square root of 3. The conjugate is 5 minus the square root of 3. And we need to also multiply that on top, 5 minus the square root of 3. Now we know that on the denominator, this product of conjugates means it's a difference of sums, or a difference of squares. The square of 5 is 25, and the square of the square root of 3 is 3. So we know that this is our denominator. For our numerator, we're going to have to use our FOIL method. Our first is 20. Outside is minus 4 times the square root of 3. Inside is plus 5 times the square root of 3. And last is minus the square root of 9. We can look at whatever we can combine and simplify. We have 20, and we have negative 4 plus 5 here. So that's going to be plus the square root of 3, or 1 times the square root of 3, minus 3, because the square root of 9 is 3. All over 25 minus 3 is 22. And we can go ahead and combine 20 minus 3, and that's 17 plus the square root of 3 over 22. 3 is a prime number, and 22 does not have any radicals, so this is as simplified as we get. Let's look at one more division problem. This one has variables in it. We have the square root of m minus the square root of n divided by the square root of m plus the square root of n. Now we don't have any special little tricks to deal with conjugates, but we do know that our first number is our numerator and our second number is our denominator. So let's go ahead and set this up in rational form. And we know that we want to multiply by the conjugate. And the conjugate we're going to use is the conjugate for the denominator, because we want to get rid of the radicals in the denominator. So we're going to multiply by the square root of m minus the square root of n. And up here at the top, we're going to also multiply by the square root of m minus the square root of n. Let's look at how this works out now. Our conjugates is the same as the difference of squares. Okay? So, difference of squares, when we square these, it's just going to turn into m and n. So our denominator is going to just be m minus n. On the top, it's going to be a little different. Our numerator is, we need to actually use our FOIL method. And let's see, our first is square root of m times the square root of m is m, because it makes it be m squared. Second, outside is negative, because we have the square root of m times the negative square root of n. And then our inside is negative square root of n times the square root of m. And then our last is negative square root of n times the negative square root of n, so that makes it positive, and it's a square root, so it's an n. And let's look and see how this works out. We can go ahead and put our ones in front of our radicals there, and we have 1 minus 1. So we have m minus 2 mn plus n over m minus n. And that's how it works. You also could combine these together if you prefer and make them be m plus n minus 2. It doesn't really matter as long as it's all up there and they have the right signs in front of them. That's going to be the big thing that we have to watch out for.